Hi, this is Dr. Khan at the end of Chapter 17, where we'll be covering 17.6 and 17.9. Here are the learning objectives for these sections. We'll start with condensation and cloud formation. Condensation happens when water vapor, which is a gas, changes to a liquid, and that can be in the form of dew, fog, or clouds. We said in a previous lecture that water vapor does require some kind of surface on which it has to condense, like grass, like your car window, or dust and smoke in the atmosphere, or even the salt crystals that kind of come out of the ocean as salt spray. So these are called condensation nuclei, atmospheric particles on which condensation can take place. Clouds are made up of millions of tiny or minute water droplets or tiny crystals of ice. They're classified by their height and their form. So we'll talk about three basic forms, and some of these are just stems that are then used to put together to describe a cloud in terms of its form and its height. So we have cirrus clouds that are high, very high in the atmosphere. They're white and they're thin, wispy kind of clouds. Cumulus are mounds or kind of globs of cloud masses, often associated with fair weather. And then stratus clouds are sheet-like clouds, or layers of clouds that cover much of the sky. And then by height, we also talk about clouds that are cirrus clouds being very high clouds, but there can be different forms of high clouds. So these kind of thin, wispy high clouds are cirrus clouds, or cirro, from cirrus, still meaning high, but stratus. Now, if we go back to our form here, stratus means sheets or layers. So these are high clouds. Cirro or cirrus, it's kind of confusing here because it can be talking about the height, the high clouds, but it's also kind of talking about a form like thin clouds. So sometimes, again, when we see this combination, we have to think, okay, is this talking about its form or its height? Here, the stratus talks about it being a blanket or a sheet, and cirro is indicating that it's actually high in height. So I know that can be confusing, which is why we're walking through it. So just cirrus by itself, thin and wispy. Cirrostratus are very high, but like a blanket of high clouds. And cirrocumulus, puffy little white clouds that are up very high. Then our middle layer clouds have the prefix alto. So altostratus, a sheet or blanket of clouds that are mid-level, or altocumulus, puffy globular clouds that are mid-level. And then our low clouds, stratus clouds, low sheet-like clouds. Stratocumulus are low kind of puffy clouds. And then nimbus means rainy or rain cloud. So nimbostratus is a cloud that's sheet-like and low, that's also raining. Nimbostratus gives rise to those kind of, it's gray all day and raining. Not raining super hard, but it's just kind of gray and raining all day. Those are sheet-like, it's just gray and covers the entire sky and it's raining all day. So we have clouds that form vertically or develop vertically. And this is a great example of a cumulonimbus cloud. So cumulus from those white globular clusters, but nimbus meaning rain. So this is a clumpy, kind of big rain cloud. And these form from vertical development, some fast lifting of clouds. Remember that lifting, that vertical lifting, especially quickly lifting warm air, is going to cause condensation to happen and form these very high, tall clouds. Cumulonimbus clouds are often associated with rain showers, thunderstorms, and oftentimes if we're going to get a tornado type of event, it's coming from a cumulonimbus cloud. This graphic is a smart figure, and I think it's worth checking out the smart figure animation. This comes from your book and gives you kind of the different grid layout of where you would find the different types of clouds. I might ask you, for example, to describe an altocumulus cloud, you would have to be able to tell me that it's mid-level, and that comes from that stem alto, and it's puffy clouds, cumulus. Our two rain clouds that I'm going to ask you to know are nimbostratus. The stratus here kind of meaning low, nimbo meaning rain, stratus also meaning that sheet like it's covering the entire sky, and our cumulonimbus clouds. 17.9 deals with the different forms of precipitation, and you need to know terms like sleet, freezing rain, which is also called glaze, and hail. So the first breakdown of different types of rain comes from the actual droplet size itself. So rain having a certain size, and then drizzle being smaller in size, and mist the smallest of the droplets that are large enough to be felt. Snow is an aggregate of ice crystals. Sleet forms from clear to translucent ice pellets. So this is actually little chunks of ice that are falling, and this is caused by warmer air that's lying over colder air. So we have this warm air, and it's rain, then traveling before it hits the ground through a colder layer, so it actually freezes, and then it falls onto the ground as a solid. That doesn't make it freezing rain. Freezing rain actually falls as a liquid, and when it impacts a surface, then it causes freezing on that surface. So sleet has already frozen. It's little pellets of frozen rain versus glaze or freezing rain, which is super cool droplets of rain that upon contact with a tree or power line or your car will actually freeze. And here we have some of the mechanisms for how these things happen. And we get different forms of precipitation based on the layering of cold air and warm air. So if we have cold air all the way throughout, you'll have snow that forms and falls from the clouds, and it ends up being as snow, right? No melting occurred between falling from the cloud and actually landing on the ground. We get sleet when we have colder air, so snow is falling from the clouds. It then melts to form raindrops, and then refreezes to become these ice pellets, which actually what impacts the ground. And here we have the formation of freezing rain. The way that that happens is, again, it starts off as snow falling from the cloud. It melts to form rain droplets, and it melts through this kind of more shallow or kind of not as deep pocket of super cold air here, or cold air here. So what's going to happen is that the raindrops cool without actually freezing, but when it hits the surface, it will freeze. And here, when we just get rain, snow is falling from the clouds, and then it becomes warm enough where the snow melts into rain droplets, and it falls as rain. Hail is a different type of precipitation. These are larger pellets or concentric shells that form from actually being part of a cumulonimbus cloud that has a lot of updrafts and downdrafts. So these are ice pellets that form and then kind of tumble through the tops of the cloud, picking up layer upon layer upon layer of moisture around it. So it's kind of like a gobstopper candy, if you're familiar with that has a lot of different colored candy shells around the outside. So layers of freezing rain are caught up in these updrafts with these pellets that grow larger and larger in size. And eventually they become too heavy, or maybe the updraft is not strong enough in order to keep the hail up anymore, and then they fall to the ground. Some pellets can be quite large, like softball size. And again, here it's kind of showing you some of the dynamics of what's going on inside of these cumulonimbus clouds. So we have strong warm air that's updrafting, and then we have a cold downdraft here. And it's these pellets, we're going to see this yellow as kind of like the path of this ice nucleus, this embryo, that's going to come up and get covered in different layers of freezing rain as it goes up. And eventually it might even swirl around a few times and get a few more layers before it can't be held up anymore. Either it gets caught in this downdraft, or maybe the storm is ending, and so we don't have as much of a warm updraft, and the hail will fall down. And our last form is rime. Rime is freezing of either cloud droplets or very super cooled fog. And these can create some beautiful images on the surfaces on which they form. And that is it.